Hello everyone, we are the visual analysis of humans team, which belongs to OPPO Research Institute. Our members include Quan Sun, Chen Chen, Xinqiang Tao, Yan Dongguo, and me, I'm Chen Zhang. Since the amount of all annotations is too large, we sampled 200,000 samples from the original date at training set. We set the sampling interval to 18 and set threshold by category to skip the cases where all kinds of expressions scores are below the threshold. As recorded in the table below, taking the training set as an example, we got about 200,000 time steps with expression scores. Considering that the expressions invoked by the video at the certain moment is only related to the video contact before. For each time step, we start with a keyframe and collect 6 seconds clips along the opposite direction of the time axis at the video date. For audio processing, we use a two-dimensional convolution neural network to extract features and regress expression scores after converting the original audio signal into a Mel spectrum. Considering that the audios in the dataset are not limited to human voice, we use Mel filter bank with a same bank head, which can retain more high-frequency information than the Mel filter bank with same bank area. For visual, we realized our network structure by replacing the classification head of CSN with a regressing head. CSN is certainly one of the state-of-the-art for action regression using 3D convolution. For audio, we realized our network structure by replacing the classification head of ResNet for audio with a regression head. The main difference between ResNet for audio and ResNet is that in order to maintain the resolution of the time dimension in the time frequency information of the audio, the several shallowest convolutions of the ResNet for audio are only performed in the frequency dimension. In the initial experiment, we set the loss function as L1 loss combined with L2 loss. However, we found that such a loss function only regressed the expression scores corresponding to each video clip, and didn't restrict the association between the video clips. Therefore, in our subsequent expressions on audio, we directly introduced the Pearson correlation coefficient as a penalty in the loss function, and for each batch, calculating 15 expressions categories. Our ensemble strategy for the regression result of visual and audio models is to sum the values after being multiplied by the weights. The weights are proportional to the Pearson correlation coefficient, a metric of the single model. The table is part of our experimental records, and the Pearson metric is calculated on the subset of the validation set we sampled. Due to the lack of time, we did not conduct an enhancement experiment of the loss function on the visual, but on the audio, we can say that the additional penalty we introduced for the loss function can improve the performance of the model. In addition, the offline ensemble strategy is also effective. Thanks.